Welcome guys to this abandoned YouTube channel. So, let's make a new video after a long time. A couple of days ago I published this small program in my GitHub called Smallchat.c, and the story behind it is that when people are old they remember often the old good times and how much better they were compared to the current times. So we were talking with a couple of friends of mine, mostly front end developers, about IRC and the good times we had there, and there were in the group also a couple of people that were definitely younger than us and never experienced never had the pleasure to use IRC, but still I told them, I believe that writing an IRC server is something extremely interesting to do from the point of view of programming, because you have like the following setup I'm going to draw. You have a single process without threads, anything, P, which is connected to many clients via sockets, and it needs to implement some kind of multiplexing, which is at the same time the single process need to monitor all the sockets of the connected clients and do very simple operations. For example, this client will send something like a message hi, and the process must make sure that the message is transmitted to all the other clients, stuff like that. So a program like that has interesting properties in order to become better programmers, basically. So I thought, what is the simplest chat server you can write in C, which is still good enough to show multiplexing programming and the kind of problems you have when implementing a chat. And this is the result, smallchat.c. In order to make it just 2003 lines of code, I have to cut every possible corner, basically. But still, cutting corners is instructive, because you do a shit implementation, and then you can evolve this very bad implementation to something that works, and in the process you understand the trade-offs and why simple things cannot work well enough, and in this process you also realize what high-level programming languages do for you in the background. Let's dig inside the code. Sorry, I write comments. I understand that nowadays it's offensive to write comments, so please disregard the comments. Okay, so this is already interesting. The first line, max clients 100. In this kind of programming, once a given file descriptor is readable, there is an event associated to the file descriptor, there is new data to read, or maybe in other implementations that don't cut so much corners like mine, the socket is writable and we have a buffer to transfer. We need, given the file descriptor number, we need to immediately access the right client structure. So I used just a linear array, where each slot is associated to the corresponding socket file descriptor. And I have to set a fixed dimension to this data structure to keep the program simple. And then the server will listen to the TCP port 77111. Oh, maybe the best thing to do is to start showing what the program do. Compiling it. Okay, now it is listening to 7711 CP port numbers. We can use as a client netcat or telnet. So one of the requirements was that initially we could not write a client, but just use telnet. Okay, I connected and the server sent me a welcome message. Use nick to set your nickname. For now we don't set any nick. And in the other side we connect as well with netcat, which will emit less noisy output. Hey, how are you? I can write in this side. And in the other connected client I will see user 5, hey, how are you? Fine. And the reply in the other client. I can set my nick anti reds, since I will split my identity among two chats, blah blah. Okay, reds blah blah, blee blee blue. Okay, and I can see in the other window the other chat. And this is the Smallchat output. I see the connected client message, and then I see the chat of all the users. It would be nice if there was additional messaging like user 4 is now known as reds. User 5 is changed their nick to Andy and so forth, but brevity was important. So let's see how the program works. This is the structure that holds my client state. It's a file descriptor and an associated nickname. This is a pointer, so the nickname gets allocated. This instead is the global data structure that encapsulates all the state of the program. And it is declared here as a pointer, as a global pointer, that will be allocated in the main function. Let's check. Init chat equal chat malloc memset. Let's reset all the data structure and set the defaults. So let's study this data structure, which is the most important data structure of the program, together with the client. Actually, the only data structures. Here we have the socket file descriptor or of the listening socket to the port 7711, the number of clients connected right now. This is the max client, is the greatest client file descriptor connected. So when I need to perform things in this array, which is max clients at maximum, if I have just 5 clients, why I should scan the whole array of 1000 items? I just stop at max client items. And that's it. And then this array holds for each connected client at the slot corresponding to the file descriptor, there is allocated a structure like this one, client structure. Okay, this is the low-level code that if the people behind C language in the latest 30 years would be a bit more serious, we would have a more decent or more decent library. Like, instead of all this garbage, probably include net.h and create CPSoet. Instead we have to do this stuff each time, but every serious C programmer will eventually develop a library to do this kind of stuff. We create the socket, set the reuse address socket option. Otherwise, if I stop and restart my server, eventually the TCP socket becomes busy because there could be other pending connections with other clients and I cannot start the server again. This will avoid this problem. and I associate to this listening socket, to this socket, port, the specified port, and I want that each network interface in my computer will listen to connections. Then I bind my socket to this address and I put it in listening state. I want it to be able to accept connections. For the client socket, I want them to be non-blocking and without any delay. So I just set these socket options. This is trivial. And then there is accept client. It just is a wrapper around the accept system call. And if system call is interrupted by a system call, it will return with a interrupted error number, and I continue, try again, and so forth. And then I want also to wrapper malloc and realloc in order to just crash with out of memory if the memory of the computer ended, because it's futile to try to recover from this kind of errors in this kind of programs. If you write a library implementing a data structure, probably it's a good idea to signal back the error and stuff like that. But in this kind of long-running programs, often when you try to recover from these errors, you cannot really continue to perform normal operations, and the program becomes more and more complex. Everything is full of checks to make sure that there is an allocation that succeeded and didn't fail, and it's not worth it. Okay, when a client connects, I want to create a client, and I allocate a nickname, set initially a user colon file descriptor random nick. I allocate the client, set non-blocking in the file descriptor, and then associate my new client data structure to the right file descriptor nickname. Copy the nick, make sure that the slot is not already busy. This is an invariant of our program. If this is not true, there is certainly a bug in our program. And then I populate. This is chat, do you remember, is my global data structure state. And I want that in the slot given by the file descriptor, I set my data structure. So if I have a file descriptor, I in O1 constant time access immediately to my client structure. And do you remember that I have a max client stuff with the greatest file descriptor? If this file descriptor is greater than all the greatest file descriptor I already have, I need to update it. And similarly here, when I free the client and I do all the reverse operations, is this was already the maximum file descriptor, I check back in the array what is the new maximum. Note that it is much more efficient to start from max clients -1 and go in the other direction. Likely I will find very often a file descriptor. Instead, if I scan the array the other way around, from 0 to the max, I will very likely perform more work. That's it. Then this is the initialization function that we already saw, and we create the CPSoet, initialize our stuff. This is an helper function that is very important in a chat. Given a message, which is represented by a char pointer and the length, I want to send this message that I received likely from a client to all the other clients, excluding the client itself that send me this message, because I don't want, if I write hi, I don't want to see Andirez wrote hi back. Doesn't make much sense. I want just to fan out this message to all the other clients. So we just do write to all the clients. And here we need to pause a bit. When I perform write, this is what is really happening basically. Let's remove this one. Okay, so I have a file descriptor which is like 5, but inside the kernel space, this file descriptor has some space, an associated buffer. When I call the write to system call, what happens is that I write in this buffer. Then the operating system in the background will try to transfer this buffer to the network adapter, whatever it is. But if the client is full, if the socket buffer is full, because for example there is a congestion and we cannot output data for some reason, write to, even if I write like 100 bytes, it may return that just 3 bytes were actually transferred. And in order to make this program short, I didn't care about performing buffering inside my program. I just hope that there is always enough client buffering. And in practical terms, this most of the times kinda works, but it makes this program broken. And in the next videos, we will evolve this program in order to fix this issue. Similarly, we do the same with read, claiming that there is always a well-formed line in the socket buffer when we read the chat from the client. But this is not necessarily the case. Maybe it may happen that this is the server, this is the client. The client writes me, the full message is like, hi, how are you? And maybe in the first data packet, I have just this part of message. So the message is not complete. And I should buffer what I read and write till I find a new line, basically. New line. /n or whatever. /r/n. So this is not correct, but we don't care because we want 200 lines of code for now, and that's it. How do we do multiplexing in C? The simplest POSIX API is the select system call. So we provide a set of file descriptors that will be trigger an event if they are readable, another set if that will trigger an event if they are writable, another set for errors, and then a timeout, maximum time I want to block inside the select call, and it will return me which is ready or not for reading. So since I cut all these corners, I am just interested in reading in file descriptors that have data, because when I write, I don't do any buffering, I just write best effort, whatever is transferred, I don't care. So I zero my set of file descriptors and I set the socket file descriptor, because if it is readable, it means that there is a new connection to accept. And then I also set each file descriptor of each active client, and then I set 1 second timeout just for the sake of it. We could even block or whatever. And my maximum file descriptor, because select wants also to know the maximum file descriptor which is set in the read set, in order to avoid wasting work, exactly as we did before. So I calculate, I have my maximum file descriptor, but the server socket may be higher than any other file descriptor associated with a client, so I also take the maximum between this and the server socket, and I use it +1. This is a select requirements that you give it the maximum file descriptor +1. You know, just to make the API more ugly. Now, there must be probably a reason, but looks like odd. And error trapping, and once the select returns, and it will return with the number of events, and if this number of events of readable file descriptors is non-zero, let's check if the server socket has a new connection to accept. I use accept client. We saw it. Do you remember? Accept. I get the file descriptor, the socket descriptor of the new client, create the new client, send it a terrible welcome message. After reading this welcome message, you want to quit the chat, basically. And I write it best effort, who cares, no buffering. And then I debug log something. And then I handle all the clients that instead could have already sent some data to the server. So from 0 to max clients, including, of course, if there are empty clients in the middle, because it doesn't. I'm not sure that every file descriptor is populated by an active client. Maybe I saw it connecting from 1, 2, 3 to disconnected, and now is set to null in the global state. So I skip disconnected clients, and if the file descriptor is readable, I read. And I here in the comment, sorry for the comments I wrote here, we just hope that there is a well-formed message waiting for us. But it is entirely possible that we read just half a message. In a normal program, this is not designed to be that simple. We should try to buffer reads until the end of the line is reached. CRLF, basically end of the line, or just LF, which is corresponding to \r\n. So how many bytes I read? Error, free client. 0 means end of data from the client, so the peer closed the connection. Disconnected client. Otherwise, I just make sure to terminate my buffer. I remove trailing. This is, and then when I receive the message from the client, I want to understand if it is a normal message or a command. Command starts with slash, a bit of C pointer math in order to parse in the more crude way, or the raw way, my string, and then I just support a single nick command. This will just allocate a string and set it. That's it. Otherwise, if it is not a command, I just want to fan out this message to all the clients, and I have my very nice helper function. And of course, before I created the message, which is just a nickname concatenated with what the client sent me. And that's it. Let's take this video short. Thanks for listening. See you the next time with an update of this small program.